Welcome back to Davos. It just keeps snowing here.
Yep. So
Pounding snow.
it's still the winter.
Exactly, it's like January. Welcome back, CYSAT 2021. Last panel discussion of the day. We talked about quantum this morning. We had 4 speaker presentations this afternoon about cloud. And now is the time to discuss it and go further with our panelists. I'll do a quick round of introduction and then I'll leave the floor to our moderator today, Alex. So today with us we'll have Simon Reid from Deorbit UK. Thank you, Simon. Good afternoon. We'll have Kees van der Poel from ClearSpace. Kees is heading the ground system and mission operations. We have Giovanni Pandolfi, Chief Strategy Officer. I was about to say CTO, but CSO, officially now at ClearSpace. That talked a bit also earlier today. We'll have also with us Enrique Fraga. Enrique is a Satellite and Mission Control Director at GMV and also had the chance to present earlier today. Unfortunately, I have some bad news because Ohad Orlev from Lightloop will not be able to join the panel discussion, which is too bad because we were looking forward to have his perspective on terrestrial versus space-based cloud storage and cloud computing to have an out-of-the-box perspective. So I guess we'll keep it down on Earth for the panel discussion. And I think the idea is to kick it off with a round of reactions to the OVH incident that occurred last week, Alex.
Yeah, so that was an idea. Maybe we'll still try to cover, the new model of putting some data into the space. We'll see how it goes. But yeah, let's start with the last week major incident, at least here in Europe. So I hope, at least among the participants, that nobody suffered from big damages. And yeah, really, I really wanted to start to have some sort of warm up about your reactions on this kind of incident. So for me, so it's at CYSEC we are building our own infrastructures. We are working a lot with equipment, data centers. So yeah, for me it would be interesting to have your reaction as let's say as consumers or users of this kind of or simply observers of this kind of infrastructures. So who wants to start? Then maybe we'll start with sure. Go on.
I think generally speaking, I mean, Deorbit, the company, we build our own space. We're a full stack company, using an old buzzword to build up a satellite. We're involved in the ClearSpace, another ground station provider, and
Simon, I think your sound level is very now is better.
Sorry, is that better?
Yeah, definitely.
Sorry about that.
Go on.
I think the point I was trying to say really is that the problem with it, if the cloud goes down, is just one element of a whole system, right? So you have to be designing your system to have redundancy and for any part of that system to go wrong. So our system is, includes our whole satellite, the networks, the communication systems, the data processing systems, and every step in the way, something could go wrong. And so that the actual, infrastructure you're using for your processing is one of those. So it's easy to get, so cloud systems tend to be so reliable, it's easy to get a bit complacent, right? And you're expecting a lot of reliability from them, which is right, but nothing is perfect. So what we have is a way of having alternative ways of dealing with problems like that. even if it's a bit more cut down and a bit more sort of hacky, we can actually still survive.
Okay, so thanks. Yeah, so I think it should definitely be part of at least of some sort of planning. So who wants to continue? Maybe Kees, do you want to take on
yeah, maybe I add a little thing from my perspective. I consider myself around this panel one of the more on the client side people. So from the ClearSpace point of view, we are now fishing that industry pond where we need to get our solutions and services and software and infrastructure in order to get the job done. Cloud could be a part of that equation, and it already is in a way. So I think the question here, how dramatic this incident maybe has been, is more on availability. So is there, in a way, best practices have become a promise that wasn't really kept? I don't know how to say it more specifically than that. Was there a service not properly delivered to their clients, it seems? And it's not so much about security in that sense, but the availability of the systems that you thought you could rely on. A best practice I'm thinking about is, even though your data is in that cloud, don't forget about your redundancy schemas geographically, or even on different providers. And well, the hybrid cloud will come later on in the discussion.
Okay, thanks, Kees. So maybe Giovanni, do you have a comment on that?
Yeah, so I really like the tweet of the head of OVH. So take your disaster management plan and start using it. That's I believe, you know, gives us all a kind of back to the reality thing. So where actually things fail, and as Simon read, is something that you need to take into account, of course. Also, maybe having a site or a service or whatever running on a single region or on a single data center is not really the best thing to do. Definitely, maybe it could be good, you know, for a website, or that is not really critical, but it's definitely not a thing to do for a service with a certain availability that you need to have. But I believe that the most important thing is really to actually focus on the thing that you need to have a disaster recovery plan. It's not something that you can build up when you actually need it. So I believe this is the most, something that really teach us something on this, because we keep, and I would say also on us in some cases, we take the cloud service for granted. Basically, it's something that also happened on the ground side from satellite operators. But this is, I believe it's good also in this conference, not just talking about cybersecurity, but what also cybersecurity can do on availability. And then, as Kees was saying, well, what is the impact on the actual service at the end?
Yeah, for sure. So for me, clearly the availability of let's say of services, of systems is definitely part of the, let's say, overall cybersecurity and risk management practices. Enrique, so what's your take on this?
Yes, so I mean, I share most of the comments that the rest of the panelists said about the availability, and also that the cloud somehow is given for granted, which is not true. I mean, I think that it's not only about recovery; it's also about continuity, because it's not the same to. In my presentation, I discussed about the backup of the backup. So you need to have the data in more than one place, and for sure, not in the same place that you have your system in the same cloud, because that is. I mean, now there are many systems to have a cloud into cloud backup, or just cloud to local. So there are many ways to manage backup. But this is for disaster recovery. But what about availability and continuity of the business? Because now, depending on what the asset that you put there, they may be critical. So you cannot, spend time trying to recover and putting back your data available, because there is a time critical operations happening there. So you need to be sure, and for that, I really believe that if you are going to a public cloud, you need to have a multi-cloud, not mixed, but multi-cloud at least. So those two vendors, at least for this continuity. So you don't need to have the very same assets on the backup, let's say cloud, but you need to have something enough to keep your operations going for the critical operations. So this, as the end, as Simon said, this is a system design. So we cannot just put the whole thing into the cloud provider and say, okay, it's up to you. It's not up to them. It's up to the client. And so if the Kees mission fail, is all the chain is failing. Not is the client, the software provider, the cloud provider, everyone.
Yeah, I think that's a very very good point you're highlighting. And I'm personally, I was looking from the reactions of some users on Twitter, I was quite surprised. So about people saying like, yeah, when I can like asking when they can come back for for their hard disks, and wondering what actually the disaster recovery planning means. I think the problem is that too many people, yeah, as you said, take the cloud for granted and basically think that the cloud is some idealistic infrastructure where everything wonderfully works. But yeah, at the end of the day, those are computers somewhere.
It's probably I think it's human nature, and it's a kind of a healthy thing. It's a bit like we knew that there was a virus around, but we took it for granted. And the volcano thing, again, that happened, and then all of a sudden we got volcano monitoring systems. So this is just another example of that kind of thing. It's going to keep happening, and people will wake up.
Yeah, and I think, well, that's certainly a catastrophic event, but clearly it's it's a sort of wake-up call for everyone, and we should use it as a reminder that things can burn down. Data centers are not indestructible, and so for me, a very huge part of responsibility lays on the user, on the user of the service. Okay, so what I suggest now that we move more, let's say, for questions and discussions about how to space missions. There are, as we already said today, there are some maybe legacy operations or things that were done in the old way. Today we have new space, so we have new technologies and especially cloud technologies about which we're talking today. So what do you think? What are the main challenges for cloud deployments for your organizations? Who wants to start?
I may, in this case. So because this is part of my daily life now, to how to face this cloud deployment. Because as you said, we have been, let's say, doing the satellite operations in the old-fashioned way, but it's still the safest and the known way, I have to say. So it's but it's true that the market and the needs and the capabilities that the cloud provides you, open a new space in the sense that you can do many more things and much more efficiently, and there are a lot of opportunities there. So in our case, we decided to have these two different lines. One is creating something from scratch, which is cloud design from the beginning, microservices oriented. But when you have something like this, it may work for, let's say, not operationally critical satellites, or you can evolve it, okay, with time. But then you have the legacy code, the legacy software, which is flying hundreds of satellites with hundreds of years of experience built within the software. And at the end, you wanted that piece of software also to be migrated into the cloud. So it's interesting to see how these two products evolve, with synergy between them, trying to reuse the operational inheritance that you have and adapt it to this cloud, because it's obvious. It's easy to put something on the cloud, it's a virtual machine, but that is, let's say, less useful, because at the end you will consume a lot of CPUs, memory, and so on. This is not the idea. Is to redesign and re-architecture the software to take the benefit of the cloud that you can deploy, you can scale it, you can do many things. So it's how do you maintain your operational inheritance and all the capabilities that are built in the software. And at the same time, you make something that are take the benefits of the new modern technologies on the cloud. That's that is the challenge that we are facing, and at the risk also, both. Because the customer wants the two worlds. They say, okay, I want microservices, but with years of operational inheritance, which is not, it's not yet there. We need to build it.
Okay,
I think sort of contrast that because so Deorbit's in a very different situation than GMV. So we're a startup and we're starting from scratch, and it gives us freedom to do things without the same constraints that Enrique has. And so we've been building our system as a cloud native from the start. That's both from the business systems in the company, but also the systems that we're writing to develop, maintain, control the satellite, and also handle all the data that's being created on board and processed on board and downlinked and passed to our customers as well. So in terms of your question, what are the challenges? It's really less of a challenge for us to do that than I think to set up a new system in our offices or on site. We don't need to design our own hardware security systems. We don't need to employ specialists. And so actually, that's one of the big attractions of the cloud, is actually reducing a lot of the challenges that take place when you're starting from scratch, certainly.
Yeah, I agree with what Simon said. I believe we are in a kind of similar situation, at least because we started as a company just a few years ago, and we started with the cloud and with the internet, because of course that was the only way for a small company to actually enter in this segment and start providing a decent service, I would say. Maybe the challenges are more on our side, to really go after the new services that the cloud service providers can provide, or the new methodologies, etc. So as I said before in my presentation, we started by just using the cloud in a ignorant way, let me say. So just virtual machines running in different regions and so on. And now we migrate to Kubernetes and to also start using some cloud functions. So the challenge there is to keep track of the new services and understand if they are really valuable for the service that we're willing to provide, and what are the down effects of those services, is if they are really a good solution for what we need to do, if there are something that is hidden or is not comprehensible from the start, and so on. Also, to pass to Kubernetes, for example, we take a little bit of time to really understand what were the implication and what will be the kind of improvement in our services. But I believe that at the end, the traction is coming from the market demand of what they want to have. So try to exploit as much as possible the technologies or the services that are available.
Okay. So actually that reminds me that I think, Kees, you wrote me about, you made a good point about the examples of acceptance of using and relying on cloud services. So I think Simon and Giovanni provided some context and some examples. So I know that, and we saw this afternoon during the talks, that AWS and Google actually provide some offers related to space missions and let's say managing assets in space. So actually, does someone has already some experience working with those services?
Well,
yes.
Not working directly. I'm sorry.
That's okay. So I was waiting for you to carry on.
So, not working in a routine day-to-day way, but obviously you can imagine that at the stage where ClearSpace is now, we have been going out onto the market and really try to touch on the whole spectrum what is out there. And I want to quickly touch on what was said in the previous round regarding that it has to make sense. And in some cases, for something very specific to do where you need this reliability and years of usage of a certain tool or function, you might want to stick with what you know is there. So in that sense, the truth is in the middle, but and your provider should do what they are best in. But in doing this exercise, we have come across the topics you just mentioned and the providers such as Google, Azure, and AWS as well. What I wanted to get across with my remark to you, Alex, is that actually supported by the pandemic to teach everybody that distributed ops can really be a thing that makes sense, that there is now traction at institutional level as well, and we should simply ride that wave. And this will make this will create potential for people to jump in, for operators to make that switch. And I think we're at the cusp of a change there. And I like what I'm seeing. Maybe there's other examples that the others can make.
I can take that on the getting on remote operations. So, well, 1 year and 1 week ago, we go directly in full remote. So from, we have never been a company really employing the smart working as much as possible. We were basically going to the office every day, maybe doing one day of smart working a month, something like that. So we find ourselves needed to go in fully remote from one day to the other. I remember the guys coming to the office, taking the screens of the laptops and so on, and moving home. But I believe the department that was less affected by this was the operation department, because everything was already set up in order to support our customers and missions at every time, basically, and in any location. So, and also we supported different new missions, LEOPS, etc., all from remote from that day. So I believe that is a good example of course, we have been pushed to do that, but we already have thought about that in order to do it in a right way. I believe that we can reconnect to the thing before OVH. If you have your recovery plan, or at least you have put it in place in your architecture, then you can do this kind of thing and react quite easily with different inputs. Otherwise, you always will find yourself in the shit.
Yeah, that's for sure. I mean, all of us were sort of forced or pushed to this new reality with a lot of remote working. Well, even today we have a virtual conference, which was initially supposed to be. We were hoping that we will be all here at Davos. So yeah, clearly we have this new reality, and I think as you said, Giovanni, with this OVH incident, we have to sort of embrace it and use it as an example of how we can move forward in this new way of working. That's for sure.
I think it's broken down a few barriers and proven that things can work, even though proven to the managers that distributed kind of working can work and securely. I think your question was about excuse me.
Yeah, I think that's
a smart working
choice of remote working and home office. So we're all now used to that.
Sorry about that. It's my birthday actually. They just came in with some cake.
Whoa,
okay, congratulations!
Happy birthday!
Happy birthday!
So before you were talking about cloud providers becoming more space oriented, right? Like AWS. Building ground station networks for instance, yeah, and much more than that. And I think that's quite an interesting development. And of course, it creates more redundancy across the market, but also different scenarios. Now, one of the things that we've noticed from this difference, because we've been working with LeafSpace, and with AWS and also some other options, and that creates some differences in the security profile that's available. And so one thing that having the AWS in the loop means, particularly as we deploy our ground system software on the AWS anyway, allows us to do things like closing the encryption loop right at source, going right through the ground station up to the end. And different options are available, basically, rather than doing encryption at the space ground link and that sort of thing. And that creates some interesting alternatives which can be taken positively, but also negatively, in the sense that it creates complexity in the system as well. So we have to think about the implications of that and how that makes our system more complex if we start to make use of those special features that these providers give. So it's a bit like the lock-in kind of question that Enrique mentioned earlier. So there's a kind of, you're given with one hand and you're taken away with the other. So you have to be quite careful, but it's an interesting to be part of that, experience that and learn along the way.
Yeah, I mean, I fully agree with Simon in this. So we have these two different experiences. So we have let's say the legacy code, which is running on the virtual machines in a private cloud for controlling one of these mega constellations with different instances. And that is more or less a straightforward control, and you can, understand easily the system-wise security concerns and so on. And then we have this new software, which was created from scratch. We deployed in Amazon Web Service. We tried to connect with InfoStellar. It's like LeafSpace, and suddenly we were attacked. I mean, we have one exposure just 15 minutes after the initial setup of one of the tools, but we receive attacks continuously, although this is doing nothing real because it's just for a lab. So at the same time, we are able to, we are simulating, but with the real data rate and so on, we are simulating in between 20 and 25 satellites, LEO satellites, continuous passes with awareness and so on. And the cost in terms of the infrastructure is so cheap comparing with having those in a private cloud, that it makes a big difference. And also that you can actually rely on a lot of the capabilities that this vendor provides you in terms of storage, in terms of communications, in terms of the message bus and so on. So it's really a trade-off in every case, actually. So I will say that it depends a lot of the final mission profile, mission design in terms of security, customer, ConOps, and so on, to define what you want to pursue and what you want to achieve there.
And maybe on this last point that Enrique said, it really depends on customer requirements. Maybe one thing that we need to do as an ecosystem is to push maybe some new customers coming in the market to understand the need for cybersecurity and the adoption of cybersecurity guidelines in a clever way. Because what we typically find is that we have a requirement that is, okay, we want VPNs, and okay, where, how, and why. Typically, when there are other things to do that maybe are much more efficient and also making the kind of architecture that makes much more sense. So I believe we need to pass from just a buzzword, okay, and say, yeah, encryption or yeah, cybersecurity, to really have guidelines to follow that really makes the customer in our case, but in general, all the players in the ecosystem understand what is secure, what is not, with a particular architecture and so on. This is the most difficult thing that we're seeing right now. Before was make people understand what is a ground segment as a service subscription is. Now it's how to make things secure and not send plain data to the satellite, and that's it.
Yeah. Actually, for this, Giovanni, guidelines and so on, it also depends, because I know that it's not exactly the same when you are building something new with the startup approach, which is, but at the end, I'm pretty sure that none of you wanted to have to stay like this. So you want to obviously get bigger and have more customers and so on. And then the actual guidelines appear. So you have DoD guidelines for security. You have the different defense ministers giving you certification process for your whole network, for your whole system, that you have to have real secure networks, and you have to certify all of them. Again, I come back to what someone said at the beginning, there is a lot of system design. It's not a solution itself. There is nothing. If we want to close a solution, we are going to fail, because the good point of this cloud approach and the infrastructure is that you can actually have a lot of building blocks that properly plug together and secure together with all the capabilities. You may fulfill all the guidelines, but the guidelines are there. There are a lot of different, with a lot of security, very detailed requirements that you have to fulfill to be able to give them service.
I think that's an excellent point that you are raising, Simon, and actually there is a question which goes through my mind right now. So I was reading a couple of days ago that someone was saying that we are missing actually standards for new space. So you were speaking about DoD types of standards. So what do you think? Do we need standards right now for new space? So how would you feel if let's say a European Space Agency or I don't know, at some government level, we would be imposed with some really strict standards about cybersecurity for let's say for new space type of missions?
Well, I think it's a matter of tailoring for the situation. So what does new space mean and old space and all that? So, it includes a whole realm of things, including student satellites and things which kind of don't matter so much, right? Up to things which are more important for the customer or commercially, up to kind of systems which are linked into our critical national infrastructure, right? So all of those need to have solutions that are appropriate to the kind of the need, and there's a big difference between sort of really mature systems that GMV have developed for their telecom customers, really high value assets, and it's a very sort of mature product, but that is a little bit too, a lot more than you need if you just want to fly a CubeSat. And also the implications, the implications are different if something goes wrong. So standards are a good thing, but you need to sort of apply them with a common sense. I think that's a main lesson learned, I'd say.
So you would say let's say for students type of satellite, you would say, yeah, they can maybe be more relaxed with respect for standards. For bigger and more important missions, that would be a good thing.
Yeah, exactly. So cybersecurity, if you're talking about security standards, student missions are fundamentally, they're probably open anyway in the data that they want to share and so on. They might be experimenting with quantum key or particular, experimenting with cybersecurity as part of that experiment. So I wouldn't try to be too prescriptive, but safety and security go next to each other, and that needs to be driven by the right need.
I can make maybe an example. So I believe it's the same kind of process that we have seen on the communication protocol side, probably. So when we started, I believe the major part of the customers that we had at that time were using AX25 as a protocol, so a really easy amateur radio protocol. And then as soon as the capabilities of the mission started to grow or to be more commercial heavy, they started to move to actual standards. So to CCSDs, to DVB-S2, not just doing strange implementation of those standards, but really applying to the implementation. And I believe this is mainly driven by the fact that when you go up in performances, you start to rely on vendors and stop doing things by yourself, basically. And so vendors typically apply the standards because it's the, let me say, easy way to do that. I believe that maybe we are on the same kind of curve also for cybersecurity. So, or in general to mission operation for CubeSat and small satellites. So where we are seeing that, okay, we can do these kind of things with this technology and with this following these in-house developed guidelines, and then there is this kind of thing that we need to do to provide a commercial service that needs to take care of different things. So I'm also talking about preparation on CubeSats. Students of course can have a lower kind of need maybe on cybersecurity, but if they have a propulsion system on board, that is a thing that needs to be addressed because anyone can hack your satellite and just moving it around. And maybe this is also a thing where we lack maybe the regulation part, not really the guidelines part.
Yep, thank you, Giovanni, for commenting. Yeah, so I think standards are sort of a double-edged sword. So of course it limits, I think, some let's say innovative approaches, but at the same time, yeah, we have to rely on standards for more complex and critical missions. So we'll see where it goes. So actually, I had another question, and it would be interesting to see how Enrique, who is let's say more in a transition from what I understood from let's say more of legacy way of managing the mission, and also Giovanni and Simon, who are building things from scratch with the help of cloud technologies. So which cloud service model? So you have this infrastructure as a service, platform as a service, software as a service, and recently even functions as a service, where you just can throw some code into the cloud. It will execute and return some results. So what would be your let's say recommendations, or how do you see this different service model going for space and helping new space missions?
So I mean, for me, in my case, is something that we have done the trade-off, and because I mean, for the satellite control, we are migrating the legacy, and for other products, obviously, we start already from the cloud at the very beginning, fully microservices oriented. So at that point, you need to decide what to do, and I mean. And we have like a mixed solution. It's like a twofold approach. We would like to think as an infrastructure as a service and try to go as far as you can as a platform as a service in an agnostic way. Because if you go too much, I will avoid software as a service so far in this. Not for everything, but almost, because I will prefer to deploy my software into the customer and then give my platform as a service that they can install my software. For almost everything, maybe for mission planning, that we also have a project there, you can give something which is actually completely software as a service. But the software as a service has this constraint that is very difficult to have ad hoc modifications per customer, which until now, maybe the whole thing is changing because there will be much more players. Until now, the number of clients, the number of users are limited, and they really want to have their own needs implemented in the software. As if you put software as a service, is okay, this is the same thing for everyone. You can do some tuning and so on, but at the end, the complexity may not worth it. Platform as a service has the advantage that you are relying on a lot of the functionality that are provided by the cloud vendors, but you need to to design the system in a way that you are not locking in with a specific vendor. in that sense, you need to think the system as an infrastructure as a service. So they provide you the virtual machine and you put whatever you want within, and then try to maximize the usage as part of your system of the platform. So for instance, we are relying on the database, some of them. We are relying on the message bus, also some of them. So on the platform, that's our approach. But always be able to deploy, and then many customers would like to have the mixed cloud, so a shared cloud within the private cloud and a public cloud. So you need to be able to deploy your system in a private cloud. In that sense, your system should be able to deploy the whole thing. In my case, and obviously, we are not towards a fully as a service monitoring and control of satellites to all of our customers.
So may I take on my client hat here again and just quickly react to that, because we have been doing this exercise of trying to gauge the market, what is out there for us and what we're looking for. And we conveyed this to all the people who want to partner with us. We shared that the only thing we can be sure about is that the goalpost will move and the objective might change. So I need to be able to control, to have active control while remaining intact with the building blocks of what the system does. In some cases, for example, the software as a service, this could be too close to the old concept of this is just the way it is. Take the piece of software, use it. And that's exactly what you're trying to convey, I think, as well, Enrique. But so that's the thing that will make it more difficult for an emerging commercial player to get that commercial viability out there. And at some point, you need to be able to turn on a dime and make that change, but continue with operating something that already flies, but you still need to integrate and you need to keep on going. So the attractiveness of, or the attraction of the cloud in this sense is high, but it must not be destroyed by putting things on it that are in the old mindset again. I just want to quickly grab back to a previous statement about tailoring a standard or using a standard as is. As you might expect, ClearSpace is very much in this gray area right now, trying to find what the best balance is, how to do this. And yeah, it's not all bad, let's say it this way. It's definitely, there is a lot of meaningful knowledge in there, and to distill it and to make it applicable to something that you know will change in the future, that's a hard exercise. It's maybe the most critical one for us right now.
So I've got a use case for this question. So we're in the process of, we've got our delivery service into space. So we're our space taxi behind me here. So we're doing launches regularly once every few weeks and taking CubeSats into space, but also payloads on behalf of customers into space. And there are a number of functions connected with that payload process, that payload hosting. And the first one of those is control of the payload, so switching on and off and changing the mode and control and deciding if it's going to take pictures and so on. That is something which we are arranging as a software as a service, so our Aurora software suite, which then allows a kind of standardized control of that. It is tailorable and configurable, but that is a software as a service. Now, but then the payload is then, say it's a camera, it's generating data, which is being processed. And we are in the process of creating a platform that manages that data processing chain from the sensor on the spacecraft down to the ground, and then turning that data into real information. So in some cases, the customer will just want that as raw data. But actually, we're adding value to that with a platform as a service, which allows them to be programming what manipulations are done to that data. So we've actually started with a ground-based platform as a service to just store the data and process it and make it available. And now we're implementing that on board as well, so that there's programmability about whether some of that data can be filtered, or whether you can identify features in that and make automatic decisions perhaps on board based on that data. So that's more of a platform as a service, because it's programmability on behalf of the customer. They're the experts in that data, right? That belongs to them.
Thank you, Simon.
Just an additional comment, because I was saying that the software as a service is not the model, but it depends a lot of the use case, as Simon was also pointing out for the platform. Because, for instance, we have something which is for collision avoidance, and that is completely software as a service. So because actually the user is not willing to change that software, it's just willing to have the service. So they're willing to have the data and to understand if the satellite is going to hit another one or is being hit by a sort of object and what to do about it. So it depends a lot of on the final usage. If there's something that the user wants to do things within that software, or just to rely on the data that this software is providing. So it's not so easy. There is not a single answer for any of this question, but it's a very interesting topic anyhow.
Actually, I have an interesting question from the chat, and actually I also encourage people who are listening to our panel to ask the questions in the chat as well. So actually, and that was a question I was also thinking about to ask. So maybe you've heard about you definitely heard about the CCSDs, which is the Consulting Committee for Space Data Systems. So the question is actually, so there are some number of documents which was published by CCSDs, which are not standards, but more like recommendations. So the question is it really difficult to follow the complex CCSDs specification for small sats and new space projects? So what is your take on this?
I can go. So it depends. I believe it really depends on on your approach to the CCSDs documents, and really. So if you are approaching them from scratch, it could be quite out of mind for you, I would say. Then you get used to them. There are maybe some more, for us at least, of course, some more important things than others. I believe that the way forward is, as Enrique said, for the as a service model, really understand what is really needed for you. Maybe the full CCSDs implementation is not something that you need to do because you don't need to interface with other space agencies, for example, or because it doesn't make sense with the kind of service that you want to do, or with the performances that you want to achieve. For example, we have few customers that moved from CCSDs at the start for the high data rate expand downlink, for example, to DVB-S2, just because there were already something cheap and really high performance with all the variable mode calls, etc. And I believe this is the same thing also for other parts that are covered by CCSDs. I would say in general, it's good to dig in CCSDs and also with the ECSS is the same thing, to dig in the standards and understand where the value is on using those standards. This is the important thing. If you just say, yeah, I'm CCSDs compliant, that is the main thing that we hear from the market, and then they are not. This is not the thing. So you need really to understand what the standard is providing you as an added value, and not just trying to apply it as you can.
Yeah, I really agree with that. It's taking the value out of it and finding. But it's not an easy journey necessarily to learn that, because everyone will take different value from different parts of the standards. And even, and there are a lot of memoranda and information around the standards themselves as well that try to give guidance. But that just adds to the amount of piles of documents that you have to read. It's not that easy. But it does depend on your case. And if you're starting out, you don't need so much. There are a set of standards called mission operation standards from CCSDs that have been being built. I think I was involved in like 2003 when the first ideas came out. And they are mature now, but they're not widespreadly used. But there is real value in that when you're working in situations where, like, we are sort of plug and play kind of technologies and very complex missions where you're involving lots of instruments and automation and things across a wide network, that it is worth making the investment to learning that stuff. But I'd say, again, not follow it slavishly, but find out the useful stuff and use it.
Fully agree. But I have to add that now, thanks to the new space and these CubeSat wall, when you can actually plug a card there and try to experiment and create new things, the possibility that there is a specific CCSD platform, let's say cards, FPGAs, that can make the world easier for the new space. So I see some movement there that I really will love to have it, because the standards at the end, they may be difficult or not, but helps a lot. At the same time, 1 year before Simon started the mission operating service, there were already the packet utilization standard for you in the European agency. And I've been, since 2002 till 2 years ago, has been not used at all in the commercial satellites. So it has been the major standard for the European, the ESA missions, but nothing outside that. Now, but now that the European satellite manufacturers, the big ones, start to using them, my world is much easier, because there is an upper layer on the standard. So CCSDs means nothing. It's just a compatibility. Every mission I implemented in CCSDs, we need to deploy the whole protocol tuning every time. So it's not, let's say, a purely defined standard. But once you start going up onto the standard layer, is much easier. PUS is one layer ahead, and mission operating services is almost everything, because you can manage on the ground and on board the very same messages. So that will be a huge step. But it's true that it's not easy, and it may have a business case behind. The good point for the new space is that you can plug and play things onto the space and try to do it faster and easier, which is, for me, I really push you.
Interestingly, there's actually, it might be a full circle in that we're currently experimenting, because again, with that end-to-end connectivity through AWS, we're actually beginning to get to a point where we can just apply other protocols, like an IoT stack or something like that. So we can actually find ways to get rid of CCS completely. And with new space, there's so much opportunity for doing things that haven't, really been tried yet. And there's a lot of opportunity for really taking sort of the whole space industry into a sort of a new era on this topic.
I believe one of the main showstopper is that a major part of the people involved in new space is not coming from space, or not coming from previous experience in space. And when you open a blue book of 200 pages, of which the first 20 is just index and glossary, then you have software developers throwing it away from their desks. So maybe just having a much more useful documentation, or usable, documentation, that would be really great, because it's just for mindset, but it will really help. This is a thing that we have done, for example, for our interfaces. We've seen that at start we had some difficulties, because we were not providing physical ICDs to our customers, but just a link to actual documentation in the APIs with examples, whatever you need to actually make it work. And at the start, it was really, really hard to make it clear to the customers. Right now that it has changed a little bit, it's all on that direction. So no one wants any more physical ICDs. They want just some usable and useful documentation. So you can really understand what is the value on that.
So I have a follow-up question coming from the chat, and I think this one is also interesting. So what is your perspective on national security implications of your architecture or your customers' spacecraft, or are there any actually implications? So maybe there is no implication for national security.
Difficult question. I mean, I guess, I mean, for the services we provide, it's more about our customers. Our customers are commercial customers, but they could have a very, their own mission could have a national security implication. Right? So if it's an Earth observation mission, that's, we're able to put satellites into very specific orbital locations. That might be that they're on an observation mission that has some particular implications, whether that's on the ground or looking at another spacecraft or something like that. So there's definitely has the potential, I would say, but I wouldn't say that new space has this sort of. I don't think we're there yet. New space hasn't really emerged sort of up to that level of those kind of applications yet. Even though the capabilities are there, currently I don't think there's much in the way of procurement of new space type of applications that have national security implications. I think that's probably where putting it at the moment.
So just there are national. I mean, there are like two things here: the new space and cloud and security. For sure, the cloud and security, I mean, has a lot of national security implication depending on the system that you are deploying. If it is a critical asset for your national security, there are things that can be deployed in the private cloud, but there are also some other constraints and guidelines that you need to fulfill. So that's part of the usual, normal cycle. And then the new space, I mean, I agree with Simon, but if you know that Europe is not that we are following US, but when you go to the ground, some of the conference for the ground segment in US, you see how the Space Army, now there was the Air Force, now it's a Space Army. They are thinking that, changing the concept into a new space concept. So they are launching swarms of CubeSats to do the observation with different instruments. And they are actually giving projects to startups that are participating in the phase A, in the design, in the proof of concept. Obviously, all the figures there has another figure on the on the right side. So it's a lot of money in the new space market to develop the new concept. So and that is specifically designed and devoted for national security. So I guess that there is a lot of potential also in national security for the new space movement, and a lot of, let's say, cautions and guidelines and procedures to follow with the cloud. But we also see, both Microsoft and Amazon, they, for the storage and the cloud computation, they already have secure services with a lot of certification for secure services for the US and for Europe. So I guess that there is a lot of field in front of us in that sense.
Let me just touch on that. You said you're making the example of the Gov-rated cloud, right? So that in Amazon, you can be in a certain cloud that is so secure, you're going to be fine. However, this is all US personnel on US machinery, on US networks, and we may have some clientele that doesn't really like that either. So we need to be able to be flexible and redeploy and be able to move somewhere else. And I don't know, I wasn't up to speed completely on the European equivalent of that, and if that would be enough, actually. Besides that, when I mentioned earlier regarding the goalposts moving at a sensitivity of the data kind of aspect, this could mean that once we are in the business of commercially doing active debris removal, time after time after time, that yields certain types of information of that debris we're going to take away. And they might not always be parts of upper stages or whatever else. They could have been items that, in a sense, cannot see the light of day. So we must have a sensitive pipeline regarding that. So it's not merely a matter of national security, but of integrity of the owners and what they don't want to disclose, but they do want to take down.
I see a couple of things here. One is the, kind of, again, guidelines or requirements that you may have from national security activities or national security missions that actually reflects on cybersecurity. There are quite a lot of other guidelines that instead is more on the company processes, on how the company is structured. If, for example, taking the example of the US, if you are a US company, how many shares the US citizens are actually having on that company, and so on. So it starts maybe from cybersecurity, but it really goes down to the processes of a company. And as Enrique said before, US, I would say in this case is much let's say pushing on this, of course, because it's the kind of heritage. And there are a lot of programs like for the Air Force Research Lab, for example, where you start small with the startups, you maybe develop a small mission, and then you continue to develop that mission following the requirements of the Air Force, etc. So you actually build up your system will take your service and you tune it for that request. In Europe, we are not there, but because we don't have a federation of European states, I would say, or European army, and so every country has every time every country does whatever they want, and also on this, the application of CubeSats directly for security or defense mission, it's really, really low, if not zero. There are more maybe usage or agencies buying data from commercial entities, but not really defense missions, as Cosmos, SkyMed, or other bigger satellite missions.
Thank you, Giovanni, and thank you everyone for commenting. So it's interesting. So we sort of went a bit away from cloud security to proper, let's say, more security, and now we are going back with what Kees mentioned about comparison between the US way of managing cloud, where they are really separating Gov cloud and let's say public usage cloud, and of course I think in Europe we still have a lot of things to do and to build around this type of approach. So well, I see that there are, well, I have more questions, and I see that more questions are coming through the chat, but unfortunately Matthew came back and is telling me that we should wrap up a bit.
Yeah, I'm still tempted to take that last question in the chat because I find it interesting. Don't know.
Well, I can try. Well, I can start answering.
Last one, and then we
okay.
wrap up. Okay.
So I can start answering this last question, and there is one more which arrived. So the last question some seconds ago was what cryptographic services would be the most critical in a cloud architecture. So I will give my answer. So actually it's all the cryptographic services, so all the services which are involved in handling keys and sensitive cryptographic material. So usually we are speaking about hardware security module technology. So these technology are now more and more moved to the cloud. So it means that these hardware security modules actually can be remotely accessed and operated by users. So you don't have to actually put it on-prem inside your data center, and those are also comes in in some sort of certification. You have FIPS, you have different common criteria. So those are the most critical services, one of the most critical services for cloud architecture, definitely. So I don't know if somebody wants to add to this.
Very, very quickly.
Yeah.
What we can say over that.
I think that was a pretty good answer, Alex. And last one also quickly, maybe for you, Enrique. Is there such a thing as a certified ground segment as a service?
Not that I know. There are ground segment there are many with ground segment as a service. There are the specific word is more on Giovanni, I guess. But because the ground segment as a service is not just about the ground segment antennas, but the ground segment is a huge, bigger system that, depending on the mission, has a lot of implications. So there is no certification on the ground segment as a service. Each ground segment provider provides their own capabilities, secure access, and so on, and they are actually quite useful. But as certification, not that I know. But
I can add to this. So certified means against what kind of certification? So we just spoke about standards and for let's say for cybersecurity for space mission. Of course, I think for ground segment there are some ISO 27001 type of certification which are applicable, but I guess yet there are no proper space mission cybersecurity certifications for ground segment.
I think there's a word that Giovanni mentioned earlier, was regulation. So there's a process of regulation for every mission, and they are asking questions of every mission as to what, that would include questions about the security of the ground segment. And that's going to be different depending on that mission. So Kees will be being asked lots of difficult questions. The nature of ClearSpace mission is very sort of fundamental, has a danger to it, because you could be creating lots of more debris, even though you're trying to remove it, right? So I think that leads to a kind of ad hoc. That doesn't mean it's any less rigorous, but it's not a case of having a certification that you meet and it's standard for everything.
Yeah, I believe right now there's nothing for certification. As Enrique said, it depends on how do you define a ground segment. There are a lot of different definition and a lot of different implementation, I would say, of it. Right now, I believe the only way to go for a customer is really to have a clear understanding of the service architecture that they are providing, that a ground segment as a service is providing to you. And in some cases, not so clear, and it is even hidden. So this is a call to arms, I believe, to all ground segment as a service providers, really make it understandable and easy to assess. This is something that we were trying to make it so that our customers are aware of what they need to do and what we are asking them to do. For example, the end-to-end encryption, etc. But no, unfortunately, there is not yet any kind of certification.
But talking about the 27001, for instance, I have the software. We have the certification. You want to include as part of this certification, my certification, the ground segment as a service of Leaf Space. It's just a matter of discussing with them and putting some constraints and regulations and audits, and I will, let's say, incorporate them as part of my certification. That is feasible. So I never did it before, but it's feasible. It's not. It's not a big deal for that certification, which is just a system security certification. Okay.
Okay.
Great. Yeah, great. Thank you so much.
I hope. I hope you enjoyed the panel, and I hope also it was interesting for the audience. So yeah, thanks. Thank you guys for an interesting discussion. At least for me, it was very enlightening and very fun.
Thank you, Alex, for moderating, doing a great job. Thank you, Simon. Thank you, Kees. Thank you, Giovanni, and thank you, Enrique. Maybe before I move on and while we say goodbye to the panelists, I would really like to, first of all, congratulate Giovanni on being nominated in the Forbes 30 under 30 list in Italy, really showing up that new space companies are being under the spotlight including in Italy. So congrats, Giovanni,
Congrats.
for this
Congratulations.
nomination.
Thanks,
It's a great promotion. And also a big
I owe you a beer then.
yeah. Also a big thank you to ClearSpace, Giovanni and the team for being very supportive about the event. They're one of our sponsors. You can see the logo down there, along with the large European organizations. And so we would like really to thank ClearSpace in general a lot for making also CYSAT possible. We have the support of the big organizations, but having also the industry and especially the smaller player, the newer player involved, I think it's a great sign. So thank you, ClearSpace. Thank you, Giovanni. Thank you all. Thank you, Enrique, for the great panel discussion.
Thank you all.
We hope
Thank you, and next year we'll see you there.
Exactly.
Hopefully.
Forward. Bye bye.